Dr. Hovind, I love your doctoral thesis. I've torn it to pieces with house and gaffle. I can't remember when I last pissed myself laughing. It's a good thing the thesis mopped the piss off the floor.
Welcome to part 60 of this read-through and peer review of Kent Hovind's doctoral dissertation, which was published on wikileaks.org on December 9th, 2009. If you have not yet seen any of the previous episodes in this series, then I recommend that you go back and see those first, as in this episode I will be starting off exactly where I finished off in the last. In the last episode, Kent told us that taking only evidence that supports a preconceived idea and rejecting all other evidence is not very intelligent or scientific, if only he followed his own example. In this episode, Kent gives us a few examples. Take it away, Kent. I will give just a few of the ways to show that the Earth and the solar system are young. Kent, I'm going to guess that those few things are probably the only way of proving that the Earth and the solar system are young. But do go on. I have a list put out by Henry Morris of the Institute for Creation Research, a list of 76 things that show the age of the Earth to be very young. Yes, Kent, and it's such a great shame that you don't actually give us a reference for this list so we can go and find it and laugh at it. But then again, the Institute for Creation Research puts out so few technical papers, as they call them, and no scientific papers in mainstream scientific journals. It won't be that hard to track down. Now, carry on. Here are just a few of the evidences of a young Earth given by Dr. Morris. Yes, Kent, and he's a real doctor as well. I mean, his bachelor's degree might have been in civil engineering and his master's might have been in hydraulics, in the same way that his PhD was in hydraulics, but that of course makes him a scientist and eminently qualified to comment on biological evolution. But carry on some more. Example 1. The influx of cosmic dust to the Earth indicates that the Earth is less than 10,000 years old. Yes, of course it does, Kent, because, let's be honest now, a satellite the size of a bus will burn up and vaporize as it enters Earth's atmosphere, but dust particles, they'll get through. Maybe the atmosphere doesn't see them, and that's why they don't get burnt up. But most of this dust has washed into the soil. This cosmic dust that comes from out of space contains a high percentage of nickel. Scientists have searched and searched for the nickel content in the Earth's crust. The amount of nickel is not great enough to account for billions of years. It only accounts for several thousand years. Yes, Kent, that's because Dr. Morris got his sums wrong. He based his calculations on samples taken from within the atmosphere, and this also contains dust from the Earth's surface. Similar studies done more recently using satellites above the Earth's atmosphere indicate a flux rate of round about 1% of what Morris quotes. Anyhow, for instance, the influx of helium-4 into the atmosphere indicates something less than 175,000 years. Pardon, Kent? Helium-4? 1 minute you're talking about nickel meteorites and cosmic dust, and the next minute you're talking about helium-4. Have you been getting your examples mixed up? Or over the past 18 years has that particular example sort of like risen up through the page and escaped the following example, example 2. Either way, we'll dismiss it as a dumb fuck getting muddled. Example 2. Radiometric decay produces helium, which has to escape into the atmosphere. Or into the previous example, as was noted earlier. By measuring the helium content in the atmosphere, we conclude that there could not have been radioactive decay for billions of years because there isn't enough helium in the atmosphere. Really, Kent, you have noticed that helium rises, haven't you? You have noticed that helium is less dense than air, so goes up. The percentage of helium in the atmosphere indicates a very young Earth. Evolutionists are searching for a way for the helium to escape into outer space to eliminate this evidence for a young Earth. So far, no method has been found. Really, Kent? Are you sure? I mean, helium, which is not as dense as air, not as dense as the atmosphere, rises to the top of the atmosphere. At the poles, where the Earth's magnetic field isn't quite as strong and quite as protective, as evidenced by aurora, etc., the lighter elements in the Earth's atmosphere can diffuse away into space, carried away by the solar winds. These losses have been calculated to be roughly equal to the amounts that are produced through radioactive decay. Mystery solved. And incidentally, Kent, it was Banks and Hollitzer who proposed this in their paper, High-Latitude Plasma Transport, the Polar Wind, in Journal of Geophysical Research in 1969. That's about 22 years before you wrote your doctoral dissertation, and about 5 years before Henry Morris wrote his paper that you're quoting from. But do go on. Another evidence that the Earth is young is the fact that there is still meteors and comets flying through space. Really, Kent? We know that comets and meteors break up and decay as they pass through the solar system. We have never seen one formed, that is, get bigger or larger. We have seen many break up and fall apart. Yes, Kent, usually as they're scudding through the atmosphere at many thousands of miles per hour. However, I'm quite sure that if you sat and watched a selection of meteors for a few million years, you're bound to see a few come together and coalesce. And seeing as humans haven't been around for not even 1 million years, I don't think that study's been conducted yet, do you? But anyhow, as comets circle around the solar system, they come close to the Earth, or different planets. The gravitational forces of these planets break pieces off the comets and they fragment or fall apart. Yes, Kent. And other comets and meteors just circle round the sun and go absolutely nowhere near any planets whatsoever. You know, like the ones in the meteor belt, between Mars and Jupiter. The ones that have been there for about 4.5 billion years. But do go on. Several astronomers have said that 10,000 years is the longest a comet could survive going through our solar system time and time again, like Halley's Comet does every 70 years, before it could disappear. If this figure is correct, why do we still have comets? Well, Kent, that's because not all comets come into the inner solar system every 70 or so years. I think Halley's Comet is just about the only one. A great many of them have an orbital interval of many hundreds, thousands, or in some cases, millions of years. And in some cases, these comets enter the solar system and leave and are never heard from again.